We have to look at the gel electrophoresis. The definition of the gel electrophoresis. Gel electrophoresis is a laboratory technique used used to separate DNA fragments based on their size by passing them through an agarose gel under an electric field. You couldn't understand. Likewise, you have to understand step by step. So first we have to know some introduction part. So this is the cell. This is the cell nucleus. Within the nucleus have a DNA. DNA have the negative charge by phosphate backbone. So this is the gel electrophoresis machine, and this one is the agarose gel. Agarose gel, agarose gel is the polysaccharide polymer. Polysaccharide is a carbohydrate, no? Then it is coming from the seaweed, and then the agarose gel itself let the DNA molecule travel within it. So it can allow the DNA molecule travel within it. So this is the polysaccharide polymer. So second thing, this is the gel electrophoresis machine now. So this part is the wells in that DNA loaded that wells places. The DNA loaded space called as a wells. So we have to put DNA this side, so DNA negative, so this side negative. So we have this DNAs we have move, they have to move this side. So this side have plus, must this side have plus. So this is the travel direction of this DNA molecules. Then process, becoming the process part. So process, first prepare the gel. So this is the first, but we have to prepare first. What is that? That is DNA sample. First we look the DNA sample preparation, then we come this part. Okay. DNA sample produce way. How can we take the DNA? First I say cell have the nucleus have the DNA. So we have to separate this DNA for to use for this. So DNA sample produce way is the restriction enzymes. A large DNA molecule is cut by restriction enzyme to their specific sites. Okay, this produce DNA fragment of DNA length or of different lengths. Then selected fragments are purified and combined to make DNA ladders. Okay. Then this is the DNA sample process. So we have to move the process. The first process is to prepare the gel. What is gel? That is the agarose gel. So an agarose gel is prepared and placed in the electrophoresis chamber. This is the electrophoresis chamber. So we have to put the gel, agarose gel, within this. So then second process. What is the second process? Load the DNA samples. We are already make the DNA samples now. So we have to load the DNA samples within the wells. So DNA samples and a DNA ladders are loaded into the wells in the gel. Okay, wells in the gel. Then third process. What is the third process? Apply electric current. otherwise they can't move, no. So we have to put electric field. So apply electric current. This electric current, DNA have a negative charge because of it is phosphate backbone. I'm already saying, no, DNA have the negative charge. So when electricity is applied, DNA moves from the minus electrode cathode towards the positive electrode anode. So third process, what is the thing is main? The DNA moving minus to plus. So that is the thing. And the fourth step is separation of DNA fragment. Small DNA fragments move faster and travel far. When we add the current field, I mean electricity current, the DNA fragments are moving. Like how they move? It is a machine. An example to say, this is the machine, this is the minus part, this is the wells are present, and this is the plus side. So the DNA have to move this side now. So when we attach the apply the current field, the DNA fragments are likewise moving. So every valves in the DNA fragments are moving like this. This movement, what is the factors? The size of the molecule, and the size of the molecules depends on their distance. So if it is have a small size fragment, this have a big size fragment. That's why the distance is low. So this is the important thing. So that is the separation of DNA fragments. All are in the wells now. First, all are in the wells. So other than when we apply the current, they are separated. Likewise, like this, separated. So that's why we call the fourth step is after applying the current, the separation of DNA fragment. That is the fourth step. So small DNA fragments move faster and travel further. Large DNA fragments move more slowly and remain closer to the wells. So we know what is the biggest thing. They can't move easily, no. Example, we take the humans also. The thin person can walk more than distance greater than biggest person. So that is the example for that. Which fragment is the big? It's nearby the minus, I mean starting point. Which is the small particle now? Small fragment is going further from the starting point. So then 5. Stain and visualized. When we look at how can we separate to visualized that which one? That DNA fragments are moving. Then how can we identify it? Where is the DNA fragments is there? So we have to stain. So stain and visualize. The gel is stained with the DNA binding dye and viewed under UV or blue light. So first we have to add the dye and view under the UV or blue light. So DNA appears as distinct bands. So after we put the dye and under the UV or blue light, we can separate distinct bands observed. So this is the gel electrophoresis. Uh, so this is the gel electrophoresis. So finally we have the principle for the gel electrophoresis. What is the principles? DNA is the negative charge. If it is negative charge, then they can move towards the plus charge. So DNA fragments are separated based on size. You know which step this have the separated fourth steps. So smaller fragments move farther, large fragments move shorter distance. So when we now look at the definition, you can understand thoroughly. Gel electrophoresis is a laboratory technique used to separate DNA fragments based on their size by passing through the edge across gel under an electric field. So now you can understand clearly. So we can finish this. So what you want next topic? Comment.